teach momentum, do not write momentum at the top of any page. Put a line that says to my students that, hey, there is a title and they will be invited to say what the title should be. And then, after they've come up with the title, I'll put the scientific title next to it. And so they will gather an understanding of momentum first, and then I'll tell them what their word is. So, first of all, I introduced to my students that we're going to have a lorry going at reasonable speeds. Maybe we'll ask them at this point, what's the national speed limit? So regardless of what they say, let's go for 60 miles per hour, which is the national speed limit in the UK. And as I say this to them, I'll tell them about an Audi I saw going along a road. Now, it is true that this Audi was not going directly towards the lorry. Otherwise, what I witnessed wouldn't just be the Audi rolling over quite a few times. I do explain this to the students. We stopped. The two people who might have been Portuguese, because we were in Portugal, they might have come out alive, but they were definitely going about 100 miles per hour when they collided with the lorry. They actually collided to the back of it, but I'm going to do the science of a head-on collision. Now, a car. I'll ask the students, how much does a car weigh and how stupid are the people in the Audi? The answer is very and about 2 tons. So I'll be interested in what my students say. I might add to the lesson depending on what they say. If they say 2 kilograms, I'll be a little bit worried. But I will still accept it as an answer, and I have to work with what they know and then add it up. So if the car's 2 tons, I'll say to the students, a very small car, like a smart car. Not very smart because they don't have any proper crumple zone in the front of the car. More of this in a future lesson. Don't buy a smart car is my thing. And so how much is the lorry? And so some of my students might say 100 tons, in which case I'll say, oh, that must be very dense stuff inside the lorry like lead. Or we're going to go for, I don't know, 20 tons, because it makes the maths easy. So I will not use my numbers at this point. I like the students to come up with theirs. They might have come up with something different from 100 miles per hour. If they say 98, I'm going to round it for the sake of easy maths. And similarly with the tons. Now at this point, I've written MPH, and I want to know what the M, the P and the H are, because I never like to say anything to a class without finding out whether they know what it is. What have I said? What have I written on the board? So most of the students that I've come across, as long as they're older than 11-year-olds, miles per hour. And I want to discuss this word here. What's the mathematical symbol for per? And then they'll often say, oh, there isn't one, sir. We've never learnt this in maths. We don't know what it is. And I'll say, well, if there's 5 oranges per person in the football team, how many oranges have you got? They'll often come up with 55. So if it's per oranges per person, it's 55. Divide by 11. Per means divide. If they're not into their soccer, I'll share the oranges by whatever team they are into. I might even ask the students to tell me a team with members of and how many is it. It might be lacrosse, because I don't know that one. But it's good to get the students involved. They're setting up the question. They're very interested in what is going to happen here. This is not like most books, and even most colleagues will do. I'm doing a crash. What's going to happen? They're very excited about this, and they're concentrating on it. So, I want to know what's the momentum before... sorry, don't mention that word. What's gonna happen? Well, if it's less tons and more tons, who's gonna win? If it's more miles per hour and less miles per hour, who's gonna win? We have a problem because the lorry is winning definitely on the weight score. And at this point, of course, I might put in that weight is the force downwards, and actually this is the mass. It's how many atoms it has. Let's call this the mass. Right, so at this point, weight is always downwards. Weight changes if you go to the moon. Mass doesn't. The amount of atoms is not changed by going into outer space. The weight, how heavy you are, because if you go to the moon, I could lift you up with one hand. Okay, so the lorry is definitely winning by mass. Now, what's the car winning by? Lots of students will say speed, and I like speed. Oh, careful. I like speed to start with, but speed's not very useful because speed doesn't have a directionality, and it's very important in this case that the car is going that way and the lorry is going this way. So we have something more technical, beginning with V, than speed. And often my students don't know the V word, and so I'll give them a couple more letters. It's a vel word. It starts with vel, and if they still can't get it after vel, I'll say it starts with vel and ends in osity. Because that usually makes them all laugh. And it makes it... So speed is kind of equal to velocity, but not really. Because velocity has got a vector part to it. V for vector, hands up, what's a vector? Hopefully someone will get me an answer for what a vector is. It's got a direction, as well as a number, a magnitude. So the magnitude is 100, and the direction is left for the car. So I'm going to call that, I think the lorry's going to win. And that's the reason I'm going to say, let's say that that way is positive and that way for my vector is negative. With the positive and negative, I can see who's going to win. And what am I going to do with the tons and the miles per hour and the tons and the miles per hour to see who's going to win overall? So we could add them. Okay. So in which case it looks like the car's winning with adding. And I'll discuss that with the students. Is that a good idea? Adding doesn't come up much in physics equations. Divide? Okay, so divide, this is the car winning 50 miles per hour per tonne. And this is the lorry, only got 3. So that doesn't seem, and divide doesn't seem like a good idea. We could do it the other way round. I mean, getting 1/50th, and we're getting 1/3, and that's also, what? If we divide, it means the more tons you have, the less of this velocity mass stuff we have. What are we going to call this velocity mass stuff? At this point, we need a word so I can keep from keeping saying, I can refer to it as something. We need a word for here. I'll give you the technical word later once we've understood what it really means. So often we'll come up with something like massy velocity. And that is fine. I like massy velocity. I'll put a dot there and discuss what the dot means. And the dot means times. So anyway, that's good. So it's mass times velocity. Excellent. So the massive velocity of the car is 2. Now, I haven't turned this into kilograms. Many times with physics equations, you have to turn them into kilograms to make the whole thing work. Not in the case of massive velocity. Anyway, I still want to know what a ton is. And I want to know what a ton is. And they're not equal, but they are approximately the same. And so the ton was named by the people in the UK. I believe so, is their measurement, and it's now used by the USA. The UK no longer uses it because there's a much easier ton, the TONNE, which was invented 225 years ago during the French Revolution, and Napoleon didn't like it. But because of Napoleon and the French Revolution, this much better system by some French scientists and administrators, they said 1,000 kilogram equals a ton. We're just going to call it a ton because that's kind of the way it's said. So this was from France. Cool. And why is this a better system? Well, because it goes in thousands. I don't remember the amount of pounds or stones in a ton, but I do remember it's 1,000 kilograms because it's a nice easy number. Everything about the metric system is in thousands, and centimeters, from centigrade, and from centipede. How many legs has a centipede got? 100. So there's 100 centimeters in a meter. It's a lot easier to remember stuff, right? So in the case of massive velocity, I don't have to turn that into kilograms. I could do, it's approximately 2,000. Approximately 2,000. Anyway, it is exactly 2 times 100 ton miles per hour. Times. Cool. And the truck at this time, get someone else to do this one, they will be very happy. They'll be screaming out, telling me, hey, we know what is happening. We can see ton. Who's winning? It's because it's multiplying together, miles per hour. And so, excellent. Well, what am I going to do with these two numbers? Well, that one's a plus because it's going in the plus direction. That one's a minus. It's going in the minus direction. So I'm going to end up with 600 ton miles per hour going that way. Okay. So that's kind of my answer. I've got marks, tick, 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 smiley face. However, what I want to know is what's happening now that the truck has crashed into the car. Well, obviously at this point, I've got a trucky car. Now, I have been in a truck when it crashed. It rammed the back of another truck. I'm going to put this bit in here to make it more streamlined. And there, I might discuss with the class what those bits are for streamlined for trucks that go on motorways and high roads and stuff. But I've got a trucky car, so crunchy, the truck has been squashed up. What actually happened was I was pushed into the back, into the sleeper part of the truck, and the car has also got a crumple zone, and it's kind of like this now, all smashed up. We're gonna keep our people alive though, assuming the truck has got a sleeper part in the back of the truck. Right, moving the page up. Anyway, so I need to know what's the miles per hour of this thing. I can work it out from the 600 because now I know I've got 22 tons of smashed up metal. It's going this way with still 600 ton dot miles per hour. So tons times velocity equals 600 ton miles per hour. Now, what do I do to find the velocity? I'll ask my students, and hopefully they'll see that if we divide this side by 22 tons and divide this side by 22 tons, we can see that we have 600 divided by 22 tons miles per hour. Always put the units in. Divide by tons. Those two, I will ask them before I cross them out. They will cancel, giving me an answer in miles per hour. I get them to stick that into their calculators. Now we must write here velocity. Getting bored of writing velocity, I'm going to just put V, giving them the hey, that's one reason why we use symbols. And what did science name this topic? Massy velocity. Mass times velocity, what's it called? I get the students all to copy this down and get the students to start making up their own ones. And I say, yes, this massy velocity is also used for grenades and explosions and guns. Grenades are a bit too complicated. The stuff goes everywhere. But for guns, and we will be doing the science of why you hold a gun, like a shotgun, you push it into your shoulder, rather than holding it in a prissy kind of way away from yourself, because those people that are a bit too not aggressive enough with guns, they're the ones that end up breaking their shoulders. You have to pull it into your shoulder. We will go through this next lesson. However, they're going to be making up questions, not the same question as mine. I've just done this one. I want them to make ones where the lorry crashes into the car from behind. Yes? So, lorry and car go in the same direction. What will they be? Get me the numbers. The best questions I will put on the board, and everybody else gets to do your question, if it's a good one. I really need to stop talking at this point. I have been talking too long, and I get the students now. Has anybody read the physics book ahead? Don't do that, please. Don't like it. It spoils my lessons. If you have, tell me what the answer is now. Moments. Momentum. Oh, moments. And why is it called momentum? Well, it's called momentum because that's the word the guy made up that did all this stuff, this massy times velocity stuff. It's good massy times velocity stuff. It's important to getting through your GCSEs. Cool! That's how I teach it. I hope that taught you a bit about my teaching style and how I like to teach things. And those people who didn't know, it taught them. Massy velocity is called momentum. And also, don't go ramming lorries. Bye!